everybody. My name is Jacek Korycki, and I'm here to tell you about our work at Skype that we do with Node.js. So actually, there is a lot of activity going on in Skype and even generally in Microsoft around Node.js. But at Skype, there is one service that went into production. It's called Chapter. So since this is a production track, I'd like to dive into some details of Chapter. So first, what is the problem that we are solving? So generally, the context is that Skype is going through the architectural change, shift from peer-to-peer, which is the origin of Skype, towards the cloud architecture, so basically services and devices. And in that architecture, if we have web clients, which we also want to have, there is a main requirement, which is, and then the main problem, core problem, which is how to a cloud service can send a notification to a web client, an unsolicited message, essentially. And obviously, we all know there are many ways to solve this problem, socket.io, WebSockets, long polling, and stuff like that. But what we wanted to do is we wanted to solve it basically as a service, create a single service for Skype that solves this problem and this problem only, once and for all. So nobody else has to basically be an expert in this type of technologies, which are quite difficult to scale. And the solution that we came up with is actually based on a very interesting kind of architectural idea, which is turn web clients into web services. So normally, clients are a little different animals than servers, right? So clients are supposed to call servers. And then servers want to send a message to a client, then it really doesn't call a web service. It does various things, right? That, there are various solutions for that, but it's not basically calling a service. It's not symmetrical. So what we try to do is basically, okay, let's create such an illusion that a web client is actually a server. And this is a kind of very fundamental, basically, where when this is done, then everything is a service, right? So there is not like a client versus mobile versus servers. Everything is like a computer, right? It's a service. And services call services, which call other services. There's a composition. And basically, the whole system is a composition of service calling a service. And since this is a little bit like going upstream, right? Because normally downstream is what we do right normally, but this is upstream, so it has the name Chapter. And we actually selected Node.js for this project. It's actually, not, this is a road less traveled at Microsoft, really. So, but it's actually supported, and there are compelling technical reasons that we actually built some prototyping to do some benchmarking, and we came up with the numbers, but really said Node is better than the alternative, and we went with Node. And actually, Node is created for this kind of applications, as you're going to see. And it was built, deployed on Windows Azure, which is obviously the Microsoft cloud platform, and built by a very small team in Palo Alto, DevOps style. So let's take a look at basically a basic premise. So I have basically a browser here on the left. On the other side of the internet, I have a caller. So I don't call it server, because it could be anything. It could be a client. It could be even a mobile piece of code. So what I want to do is, in this browser, obviously, there is an HTML5 app with JavaScript running. And what I want to do is, first of all, establish a unique URL, assign a unique URL to this browser, right? So and then somehow, let's say that I'm kind of transferring this URL to the caller. Caller knows about this URL, chapter.io/connection ID. And then what I want the caller to do is, basically, I don't want him to understand that there is a client and there is like various push notification services. I want him to understand that he is calling a web service, right? Using a URL, which everybody does. It's standard stuff, right? So I invoke a HTTP request. Magic happens where it's delivered to a browser, processed in the browser returns some response. So not only this is actually, if we have something like that, not only this solves like a notification problem, but it's also a better notification because you have an acknowledgement of receipt with the HTTP response. So how can we do that? Let's take a look at the core architecture which looks like this. Obviously, you cannot do it on the web natively, right? So you have to insert something in the middle. It's like a mediator. And that's exactly the Trouter service. So in the middle, between the browser and the caller, I have a Windows Azure deployment with the service. It's deployed on a bunch of servers running Node.js. And on the left-hand side, I maintain a connection with the browser. That's actually a web connection, a WebSocket, or Comet, if we cannot do WebSocket. WebSocket is preferred. It is based on Socket.io, just up front, it's Socket.io. Let's not reinvent the wheel. And obviously, SSL, because security is important at Skype. On the right-hand side, so this is actually a connection, it forms a tunnel. The whole thing is based on tunneling. And on the right-hand side, basically, a caller is just standard caller. He just invokes a HTTP request that somehow magically gets to the right server, and then it's relayed to the other end. So let's take a few steps through this. So, so browser makes an initial connection request, to the service, which goes to the load balancer. We have a standard Windows Azure load balancer. It's a software load balancer, and this is all standard stuff, which selects one of the instances running Node.js. It goes there. And we basically establish a connection, which is persistent. Basically, we keep it for like hours, right? And it's actually, this connection is creates a tunnel, a logical tunnel. Then we somehow transfer the URL. The URL is assigned, and browser learns about the URL. So here's your URL right now for this session. There are various ways for transferring that typically involve database registration and stuff. It's not part of the service intentionally. It's supposed to be simple. So now caller knows this URL, HTTPS T1 Trouter IO connection ID, and invokes a HTTP request. It's a standard APIs. We don't provide any special API. It's just basically HTTP API, right? Everybody has that. So HTTP request is invoked, and now the whole magic happens via, the most important thing is a URL, right? So you see that there is a structure in the URL, which basically, first of all, T1.router.io, it's like a self-routing URL, right? So T1.router.io gets the request to the right server, which happens to have the connection, right? So we do not find things like in database. We don't look up things. We make DNS do the work for us. That's intentionally done like that, very simple. And then that server actually looks into this URL and say, hey, this is connection ID, right there. So let me fetch the connection object, and I'm going to use it. So what it does, it forms basically a tunneled message, copies all the data from the HTTP request into a JSON object. That's a simple JSON payload, sends it down the connection to the browser. Browser processes this using the HTTP API, which I'm going to cover later, and returns a response, which is actually transferred over the connection as another JSON object, tunneled response. And there it's unpacked and converted into standard HTTP response. So caller thinks that he called HTTP request, standard, and there was some proxying and tunneling going on. It's very, very, very simple, and because it's very, very simple, it's very scalable. So I'm going to show it in a moment. But before I go there, obviously there's a bunch of things that I skipped. There's like reconnect, resiliency, and stuff. And there's also authorization, so that it's not like everybody can connect to the service. So we control who is connecting to the service, right, based on signed permissions. A web client has to have a signed permission. And there is like a bring your own authorization model where you can have basically a bunch of authorization servers that are in a trust relation with shared key with the service. And they issue those tokens, those permissions. So now scaling, that's actually the most important thing for Skype, right? Because Skype is a high scale. Anything you do at Skype is automatically high scale. So here, basically, the idea is basically to not do too much work, right? Let the infrastructure that already exists on the web, on the internet, do the work. And this is like a scale-out diagram that basically the same like I showed you before, but except that we're showing a couple of things here. So basically, there is several data centers involved. So it's not running in a single place. It's spread around the globe in several data centers, where Windows Azure data centers. Now, we also use something called Windows Azure Traffic Manager. That's part of the Windows Azure. And it allows us to do a two-stage load balancing. So the first step is DNS-based, where we basically allows us to geolocate things. And basically, browsers in US get routed to the data center in US by DNS lookup. It's basically a DNS level. After that, there is basically a TCP level load balancing, standard, like I already showed. So, this is all there, and what the beauty of this is the caller doesn't realize and doesn't care, doesn't have to understand any of that, right? Caller only understands that there is a URL and there are HTTP APIs, and somehow automatically, the request goes to the right data center, to the right instance, and then to the right connections. And when you tally this all up, well, basically, we have several data centers across the world, like roughly uniformly distributed. And in each data center, we have like on the order of several thousands of servers, which are CPU cores. And each server holds like about on the order of several thousands of connections, with some room to spare. So when you tally this all up, it comes to like tens of millions of clients concurrently connected. So it's sizable. And as far as I know, it's on Windows Azure, this is the largest service of Node.js. Let's talk about the API. So API is idea. So the idea of API is, again, let's not do too much work because things are already invented. Well, Node has a very cool HTTP module with a cool API. Everybody knows this. Why don't we leverage this? So here is basically an example, a hello world that everybody learns on the first day of learning Node, right? So I have an HTTP server, and basically it returns an echo. So I collect the data through using chunks, right? When I have the data on end, I write a 200 response, and I write basically what I got, like basic stuff. So let's see how this actually works in Trouter. So if I deploy this kind of like server in a Trouter client, this is how it looks. On the right-hand side, you see that anatomy of this is very simple. I mean, we're basically based on Socket.io, so we're loading Socket.io.js. We're loading this Trouter client.js. This is basically a small shim that gives us two things. One is the emulation of this HTTP API, and the other is the tunneling logic. And then once you have that, basically, you create a server on the Trouter object. There's one thing that is special, which is basically we have like a ready handler, which basically allows you to learn what is your URL for this session. And when basically we're announcing, in this case, we're console log to the world. And now what is interesting that the request handler is actually a mirror copy. It's basically a copy and paste. And so that's just kind of cool. That's basically a style of, this is basically Ajax application that is kind of pretending to be a web service. So now I'm gonna go to a small demo. Okay. So I'm going to load a simple application here. It's actually a minimal client. So my minimal client just connected. So I received this URL, which was printed out here. All right. So again, I loaded this client, and so I'm going to do it again. Basically, this is a minimal client. It loads, it connects, it prints the URL. So let's take a look at inside of this what we have. Very simple. So we load Socket.io, Trouter client.js, like I showed you. We create, it's a bunch of stuff that is not relevant, but we create a server, and then basically we have this onReady, where we console log the URL. And then the main thing is basically this request handler, which is here. We basically console log what we received, and then we write this response with the echo. You send a request method to fetch a URL. So very simple. So let's take it for a spin. Let me make some room here. I'm gonna Control Shift I. Yeah, console. Yeah. Okay, so I'm going to copy this URL. I mean, this is very simple what I do. Most of the complexity is in copy and paste. Really, but I'm just going to show that actually it's live, right? So I'm gonna, this is my caller, right? It could be a server, but basically, let me add foo here. And yeah, he says return foo, and I got a request, right? And yeah, I could hit a breakpoint and stuff. Or okay, we can actually, what we can do also, let's say, it's any verb, right? So here was a get because that was a browser, but I can do a curl. Let me copy this here, and this is going to be post test. Okay, so let's do this, and boom. Yeah. So we're basically processing, web services in the browser. So I'm going to go back to the presentation. So here a few details about like Node.js, because this was like mostly architecture. Here is about Node.js and kind of deployment on Azure. Basically, what it takes, there are certain things that you learn as you go with the high scale deployment on Azure. So first of all, we keep it simple. Like I mentioned, this is like a theme. We use small instances, right? Because you can have multi-core instances. We just use a single core instance with 2 GB of RAM. And there's several technical reasons for this. Is basically it's simpler. It mostly plays well into the single-threaded nature of Node, right? So I don't have to do clustering and worry about different ports. Better resilience. If something goes down, then it takes down less connections, right? It's a good thing, and things do go down, right? So also better density in a VM environment. And generally, as far as cost goes, so basically it's proportional, so it doesn't matter as far as cost. If you have a 4-core or 1-core, if you fully utilize it. And let's see here, another detail is basically that in Windows Azure, this is actually a so-called PaaS, platform as a service model, not infrastructure as a service. So it's not like you're running your own servers. It's higher level. And there's something called worker role. And that's what we're using. It's basically, it's a Windows Server 2008, on top of which we actually deploy our own Node.exe. So we get to select what we run. And on top of this, a bunch of JS, right? And essentially, our application doesn't see Windows much after this. I mean, this is a deployment kind of detail. So there's actually also interesting that there is another alternative for Node deployment, which we don't use, which is called web role. And it's kind of like a higher level, and it leverages IIS. So HTTP is done by IIS and handed off to Node. And there was issue with the WebSocket support was not there, so we couldn't use it. So we use a few modules, but there is only one kind of module that is really architecturally significant, and that's Socket.io. And this is heavily based on Socket.io, and especially for long polling. It's basically, there is a lot of finesse in getting the long polling done. There are various variants, XHR or JSON-P polling. So we don't want to reinvent the wheel. It works, let's test it, let's use it. This work was not without challenges. It wasn't clear that it's going to be a success, but a little nervous. So occasionally, there was really system management. At this scale, you have thousands of instances, you got to have a good system management. You cannot run in the dark. You cannot, remote desktop to servers. So a lot of work around this. And for example, we had to develop a native module to leverage Windows ETW logging. So it's like a Windows Azure logging. And these logs from every machine are collected into Azure table, which is like a NoSQL database, so that it's indexed. And basically, we can go with the browser and kind of search logs across the deployment, across the Earth. Planet Earth, right? We search the logs. It actually takes a lot of work, which is kind of boring, but it has to be done. Memory leaks. So that's kind of like I think, pretty typical theme in Node development. We also experience this, both core, C++, both or NJS. Some of the worst leaks were in a HTTPS client. It seems like kind of strange that it's kind of like an unsolved problem. We had to use HTTPS client in one of the variants. And then there was also slab buffer problems. So we heard in one of the talks about slab buffers. We actually had up close and personal experience with slab buffer problems in TLS connections. Somehow we kind of managed to solve all this, and sometimes we left it. Basically, the server had like several hours of life, which was good, and there was resilience. You reconnect, so it was acceptable. But we kind of survived, and we delivered, actually, so despite these problems. Garbage collection, lots of CPU goes towards garbage collection, especially for long polling. Every 40 seconds a request comes in, a lot of objects are created. Lots of CPU goes towards garbage collection. And this is all about high scale, load testing, fault tolerance, capacity estimation. We actually ended up creating a custom framework in Node.js as well for load testing. It's like a farm of bots. It is used, actually, I cannot really be more specific. It's used to send notifications to web clients. Unfortunately, I cannot share more details. But also, another interesting thing is that there's a plan to actually use it in mobile clients. Now, here, interesting bit is that, unfortunately, as much as we love JS, across all tiers, it's not really friendly with mobile. I mean, it's not happening, right? So, for battery life and all this. So actually, we ended up basically, the pragmatic approach was we basically ported these libraries, client libraries to C++. So I would like to close this. So basically, there's other node work at Microsoft at large. And I would like to just mention a few quick things. I mean, you probably heard about TypeScript. That's actually driven by Microsoft. Structured, you can do node development with more structure, like strong typing. There's a plugin for Visual Studio which allows you to, if you like it, right? Because some people like actually, regular text editor, like Sublime. But some people like a little bit more tooling, like code assist, right? Refactoring, all this. So it's there. There's Windows Azure SDK, which contains PowerShell deployment scripts. Actually, we heavily use this one. This is critical part. Also comes with some Node modules for Windows Azure services like Azure Table. There is something called IIS Node. Basically, I mentioned this already, that basically allows you to host a Node application inside of IIS. And actually, what technical reason for this is that it leverages HTTP sys, which runs in a kernel mode, to do HTTP processing. Also, maybe a last thing that I'd like to mention is there is a project in Skype called Azure Mobile Services. It's basically about backends for mobile. So mobile developers don't think about complexities of the backend. Focus on basically it's basically simplified for them. And this backend is actually powered by Node.js. And that's all I have. Thank you.